Hi everyone, this is lesson 23 on special products. Hopefully you're watching these videos in order, but just in case, definitely go back and watch lesson 22 before this one. Okay, they're kind of two parts of the same lesson about multiplication of polynomials. We're going to see some formulas in this lesson, but it really still builds on what we learned already. So you're going to hear me refer to the distributive property as well as FOIL, and that was covered in lesson 22. In normal life, we would be doing both of these on the same day in class. So pretend we just took a break and now we're back in lesson 23. All right, so here's our first example. We will be seeing these problems where you have a binomial being squared. Okay, you should know what it means to square something, multiply it by itself. Here's the thing though, there's such a common way of doing this problem wrong that I just feel like I want to mention it right away. So I'm just going to write don't and then show you what not to do. Here's what you don't get to do. You don't get to distribute that 2. It's not just x squared plus 64y squared. Sorry. So no. So now that we know that's not what we're doing, you might already be wondering, wait, isn't there a time when we distributed an exponent? There was. That was when we learned about the power rule. That was before plus and minus signs started coming into our problems. That was when we were just squaring maybe a monomial, a single term, or not just squaring, but having any exponent applied to it. Once you have a plus sign or a minus sign involved, unfortunately, we cannot distribute an exponent. So instead, there's a couple other ways we can do this. All right, I think I am going to erase this to make some room. All right, here's what we're going to do. I will show you these formulas, but I will tell you that my preference is to just write the parentheses twice and use FOIL, because we've already been practicing FOIL and distributing, so we might as well do that. So I'll show you both ways. Notice these two formulas. There's one for a binomial that has a plus sign, and then there's another formula for a binomial with a minus sign. Let's see if we can apply the formula to this problem. It feels a little strange to just plug into a formula when you don't know why we use that formula. So this might seem a little strange, I don't know. But let's give it a try. Then I will show you the FOIL method, and I think after you see that, you'll see where the formula comes from. All right. Here we go. All right, so if you can see how I lined up the parentheses, instead of x plus 8y, I have a plus b. It's almost like a is being replaced with x, and then b is replaced with 8y. So knowing that, that kind of gives us instructions for what to do next. So let's, instead of writing a squared, let's write x squared plus 2ab. That means 2 times a times b. So a is x. Let's use some different colors here. A was x, and b was 8y. So we're going to have to simplify that term in a minute here. And then finally, plus b squared. That's when I take 8y and square it. Okay, so that's quite a bit happening. And now let's see if we can simplify to get our final answer. X squared is still just x squared. This whole thing right here is all one term, 2 times x times 8y. So we'll multiply all of that together. 2 times 8 is 16, x and y. And then finally, 8y squared, that's 8y times 8y, which is just 64y squared. So remember when I said don't? The answer that I was referring to that would have been incorrect, what it was just going to be the x squared and the 64y squared. The middle term is usually what people forget or miss if they try this without knowing what to do. So notice that our answer is a trinomial, okay? We didn't get there using FOIL. We used this formula for the square of binomials. So essentially you do get to square the first term. You also get to square the last term, The middle term comes from multiplying the first times the last and then doubling it. Okay, let's go back now and let's see if there's an easier way possibly. You can decide if it's easier or not. I'm going to do the same problem again. I'll take us to the whiteboard this time. Let's do the same problem again using FOIL. So x plus 8y squared. We'll use FOIL this time. Okay, remember, to square something, that means we're writing it twice. Okay. So I'm going to take this expression and do just that, write it twice. X plus 8y, x plus 8y. Now when I distribute x times x, there's the x squared that we got before. X times 8y, that's just 8xy. All right, and now for my inside terms, 8y times x, I can write 8yx, or how about 8xy? And then finally, 8y times 8y, that's 64y squared. So with FOIL, remember, the middle terms usually can be combined. Now notice, not only can they be combined, but they're the same, and there's two of the same thing. So if we add these together, 8 plus 8, there's your 16xy, right? That's what we got in our answer just a minute ago. Okay, but what's really going on is that there's two of them, 2 times 8xy. I know those terms were rearranged, but that's essentially what we have. We have two of the same thing. Okay, and I guess just to reiterate where this formula comes from, maybe what I should have done at the beginning is written this twice. A plus b squared is a plus b times a plus b. Oh, it's supposed to be parentheses. If I distribute here, a times a squared, a times b, that's ab, b times ab or ba, and then there's your b squared. 1ab plus 1ab is 2ab. So there you go. That's the origin of the formula. So it really does come from FOIL. If you prefer to just use FOIL every time, that is totally fine. I don't find it any harder or easier necessarily than using the formula. It's really up to you. So I'm just making sure you know you have options. When you view the example on the homework, it will try to guide you towards the formula, which is fine, but I'm letting you know that using FOIL is also fine. So let's see some other examples of these, squaring binomials. All right, let's see. So number 2, trying to decide which way we should do it. Let's see, I like to write it twice, I think. It's supposed to be a 4. And then 3m plus 1/4. Okay, so how about this? I'll do this one using FOIL, and then I'll do the next one using the formula. Either one is fine. All right, just gonna edit that a little bit. So go ahead and start distributing if you haven't already. 3m times 3m is 9m squared. 3m times 1/4. Okay, so this is really 3 over 1, m times 1/4. Multiply across, it becomes 3/4, or 3/4 m, if I keep the m last. Then here's my next one, 1/4 times 3m, that's 3/4 m again, plus 1/4 times 1/4 would be 1/16 if I multiply across. All right, so once again, notice that those two middle terms are the same. So I am going to need to combine them. Now the good thing is they have a common denominator of 4. So when I add them, I keep the common denominator of 4, and I just add 3 plus 3 and get 6. So that's 6/4 m. All I have left to do is reduce. Okay, so if I reduce that by 2, becomes 3 over 2m. So let's put it all together. our final answer will be 9m squared plus 3 over 2m, and then plus the 1/16. And again, you could have done this one using the formula. I'll just say that middle term, 2ab, would have been 2 times 3m times 1/4. 2 times 3m is 6m times 1/4. Put it over 1. Oops. It would have still been 6m over 4, or 6/4 m, and you'd still be able to reduce. So that's just a little snippet of part of what the formula would be. Okay, so here's our final answer. So that one was a little trickier with fractions. Let's do this next one. Let's actually attempt to use the formula. So a plus b squared is a squared plus 2ab plus b squared. Okay, so a is this first term here, b squared t squared, and I'm squaring that, plus 2ab. Okay, a, b squared t squared, b is 3, and then finally b squared would be 3 squared. That's going to turn into 9. I think I just said squared a lot of times. So pause and make sure you can follow all of that, and I'm doing the same thing. Okay, so I got my formula. A is the first term, b is the second term, a squared. I need to simplify. Really, each of these terms has simplifying that needs to happen. All right, so let's square this first term. So I can use the power rule right now. There's no plus or minus signs in here. I can square this by multiplying the exponents. 2 times 2 is 4. So v to the 4th, t to the 4th is my first term. Plus 2 times 3 is 6, so those are the coefficients multiplied together, and then v squared t squared. Plus, and then here's my last term, 3 squared is 9. There's my final answer. So once again, I used the formula and plugged in. I could also write this twice and FOIL. I would end up with 3v squared t squared plus another 3v squared t squared. And then I would end up getting 6v squared t squared for that middle term. Anyway, all right, good. So those were examples of squaring binomials. Now I've realized I gave you 3 examples that all have plus signs. If there's a minus, just make sure you have a minus in that middle term. I'm sure that will come up at some point. It just didn't yet in our examples here. Okay, so our next formula here is called the product of the sum and difference of 2 terms, also known as the difference of squares. Okay, this formula I find much more useful and easier to remember. But once again, you can use FOIL. That is fine. Okay, using FOIL is okay. I'm going to say or FOIL. So each one of these problems is set up for you to distribute using FOIL. So just go ahead and do that every time if you want, but I hope that you start to notice a pattern here. So let's FOIL for number 1 and also notice a pattern. Okay, so x plus 5, x minus 5. All right, so x times x, x squared. Outside terms, that's minus 5x. Inside terms would be plus 5x. My last 2 terms, 5 times negative 5, negative 25. We've done a lot of FOIL so far, so I'm going a little faster. Now my middle terms can be combined, except look at that, they cancel. X squared minus 25. So with these problems, your final answer will be a binomial. It will only have 2 terms. The middle terms would cancel every time. So an alternate way to do this, if you actually use the formula, would be x squared minus 5 squared. That would be where I could get my answer. Okay. A plus b, a minus b is just a squared minus b squared. Because of this pattern right here, because those middle terms would cancel if you were to do the full FOIL process. Okay, so for number 2, I will try to use the formula, a plus b, a minus b. It fits the pattern, so that's going to be a squared minus b squared. So I'll replace a with 4w. I'll replace b with 6c. I'm squaring both of those. So the plus sign, minus sign line up. So I do just need to plug in 6c. The minus sign is kind of taken care of. Now I just get to square both of them. 4w times 4w is 16w squared. That would have been the first term in my FOIL process. And then 6c times 6c is 36c squared. That would have been the last term in my FOIL process. And the outer and inner terms would have canceled. It would have been minus 24 WC plus 24 WC. So feel free to FOIL and just verify that those for yourself, that those outer and inner terms would cancel. But look at this nice formula. You can just use that when you have this pattern, okay? So be careful. Don't use this for every single problem you come across. Only if it fits this pattern of a plus b, a minus b. The first terms and the last terms have to be the same, and the signs have to be opposite. So it's a very specific kind of problem. It is a special product. Okay, that's why we're learning about it in this section. All right, so let's keep going. Here's another special product. So a plus b, oh, it's out of order. Oh no. A minus b, that's okay. A plus b is over here. A minus b is over here, no problem. Okay, the first terms are still the same and the last terms are still the same and the signs are opposite. So it still works out. Okay, so a squared minus b squared. That's gonna be 1/3 b squared minus 3/4 f squared. That's my a and b terms plugged into the formula. Now all I have to do is square both of them. So when you square something, just multiply it by itself. 1/3 times 1/3. Feel free to write it out. 1/3 b times 1/3 b. 1 times 1 is 1. 3 times 3 is 9. That's b squared minus 3/4 b, or f, sorry. 3/4 f. 3 times 3, 9. 4 times 4 is 16. F squared. So here's my final answer. 1/9 b squared minus 9/16 f squared. So I totally skipped over FOIL. You absolutely could FOIL for this one. You'd have 4 terms with fractions instead of 2, and we just kind of bypassed a lot of the simplifying that would have needed to happen. So FOIL is fine, but I think for these problems, it is to your benefit to use the formula if you can remember to do it. Okay, number 4, this is a little trickier. I didn't really notice that this problem was in this particular pattern when I came across it on the homework. But I'll tell you now that we can rearrange some things. So see how the first term is negative? That might seem a little strange. Or it feels like we don't want it to be there, right? So I'm going to rearrange the order here and write v squared and then minus tm. And then this second term, I'll also write the v squared first and then plus tm. See, now it matches, right? Now it fits our pattern that we've been using. So a plus b, a minus b. It's just that the minus and plus are in reverse order, and that actually is fine. It could be a minus b and a plus b. As long as you have one of each, it's fine. That's a squared minus b squared. So we can do v squared minus tm squared. So notice I'm plugging in v squared for a, and I'm plugging in tm for b. V squared times v squared is v to the 4th. Tm squared, tm times tm is t squared m squared. So lots of variables in that one and some rearranging. So this one was a little bit trickier. If you didn't notice that pattern and you just did FOIL, it would work out perfectly fine. Okay, it really would be fine. So that would be okay too. Okay, good. Next, okay. What we have left now, these are almost bonus level questions, except they're not bonus. These are a little bit longer. So we will use some different formulas to make these problems go a little bit more quickly. So these are special products, but they're just some longer multi-step problems. But we're going to be noticing some patterns and using our formulas, and it'll be great. Okay, so let's take a look. X plus 3, x minus 3, x squared minus 9. Okay, wow, so we have 3 different things to multiply. In general, let's work left to right. So I'm just focusing on these first 2. X plus 3, x minus 3. Now I could FOIL, but I'm noticing the pattern, right? That's the a plus b, a minus b pattern. A plus b, a minus b, we were just looking at that. That's a squared minus b squared. So this is just x squared minus 3 squared, which is x squared minus 9. Or I could FOIL and get there just as easily. So the first 2 terms are equal to x squared minus 9. Meanwhile, I will bring down the next term. I'm saying term, I mean parentheses, expression. Okay, now I kind of have a new problem. So next, I'll say next step now. So it's almost like I'm doing another problem. Oops. Okay, so this one, again, we can use the a plus b, a minus b. Okay, so I can still use that same formula. I can square the x squared minus squaring the 9. Okay, it's just that the plus and minus are in sort of reverse order, but still it's that same pattern, a plus b, a minus b, except it's a minus b, a plus b. I can still use this formula. My final answer is x to the 4th minus 81. And that's my true final answer. So I really used the a squared minus b squared formula. That's really what helped us out here. Now, if you don't notice the pattern, FOIL is fine, as I've continued to say here. So I could FOIL with just do 2 at a time, okay? Don't try to do more than that. It won't work, trust me. Just FOIL the first 2, work your way down to get the answer of x squared minus 9, then you could FOIL again. You'd eventually get to the x to the 4th minus 81. Okay, good. I think we have one more longer problem to do. All right, this one really is a bit trickier to notice the pattern. So if you don't see a pattern here, you don't notice anything special, that is okay. I wouldn't use the word FOIL here, but if you want to just distribute, that's completely fine. So distributing is fine for this one. However, there is a pattern that I'd like you to see. So 2v plus 3p, it's kind of like that's the same first term for both. I'm just going to call that x. Actually, no, I'm not. I'm going to call it a, because that kind of matches our formula. We'll call it a. So a. So there's a plus 4 and there's a minus 4. That's like plus b and minus b. That should look familiar. So that's a squared minus b squared. Okay, so what are we going to do? Well, a squared, that's 2v plus 3p squared, minus b squared, that's 4 squared. Now there's still a lot of work to do, okay? So I still have to square this binomial, which is another formula. That's the original formula that we learned, squaring a binomial. So if you don't remember it, you can always write this twice and distribute. That's fine. But I will remind you, a plus b squared is a squared plus 2ab plus b squared. So that's what I'm going to attempt to do here. So let's see, a squared plus 2ab, 2b, 3p, plus b squared. And then I still have that minus 4 squared. Oh boy, okay. So it kind of looks worse right now, but I think we can simplify it in the next step if we just do one term at a time. Okay, so let's simplify. 2b squared, that's 4b squared, 2 times 2v is 4v times 3p, that's going to be 12vp. And then this is 9p squared. And then this is just minus 16. So there you go. It's still a long answer, okay? And here's the thing. If recognizing the formulas seems really intimidating to you, that's okay. I've known the formulas longer than 20 minutes, so they're more embedded in my brain than they might be in yours, and that's just a fact, and that's okay. Once you practice this, the whole point of formulas is it's patterns that are meant to help us. If it doesn't feel like it's helping you, then use something else. You just distribute. That is okay. All right, so another way to do this problem is you can just do this. Distribute, distribute, distribute. You know, that whole thing, right? You'd end up with 9 terms. It's just like one of the longer problem we did in our previous lesson. And you'd still be able to combine and get this final answer. Trust me, it would still be fine, okay? So it's just gonna be a long, hard problem either way. All right, so that's it for lesson 23. So those were some special products. Like I've been doing, I am going to give you a short preview of some homework problems right now. But if you'd like to be done now, that is fine. So here's homework 23. The questions do pretty much follow the order that I showed you. Okay. All right, so you can see here's number 1, where you're squaring a binomial. Okay, so we start off using that first formula, or if you'd like to FOIL, that's fine. Okay, this seems like kind of a hard one for a number 1, right? So if you like writing it twice, that's okay. 4s plus 1/5, 4s plus 1/5. It's unfortunate my s's look like 5s. Distribute, that's 16s squared plus 4 times 1/5 is just 4/5 s, and then here's another 4/5 s, and then 1/5 times 1/5 is 1/25. Now all I have to do is combine 4/5 plus 4/5 is 8/5 for my middle term. So that would be my final answer. 16s squared plus 8/5 s plus 1/25. That's writing it twice. So pause here if you need to jot that down. I'm going to show the same problem again using the formula. So I'm about to clear it. Cleared. Okay, so here's the formula. A plus b squared, a squared plus 2ab plus b squared. So that would be 4s for a plus 2ab, 4s 1/5, and then 1/5 squared. That's what it looks like to plug into the formula, okay? So a is 4s and b is 1/5. 4s squared, there's the 16s squared that we got. 2 times 4s is 8s. If I put that over 1, 8s times 1, that's 8s over 5, or just 8/5 s. So I can put the s off to the side or kind of in the numerator. Either way is fine. Plus, and then when I square this, 1 squared is 1, 5 squared is 25. So you get the same answer either way, obviously. All right, but yeah, that's not really a number 1 level question there. Kind of gives you a hard one right away. So plus, so like I said, you could write 8s over 5, or you can write 8/5 s. Just make sure the s is not in the denominator, and then plus 1 over 25. Okay. Okay, number 2. All right, here's one with a minus sign. So if you write it twice, that's fine. It'll take care of itself. If you use the formula, just make sure you recognize, because of that minus sign, you need a minus in front of your middle term. The first and last will still be positive. So this one would be r squared minus 2r 4p plus 4p squared. That's what this would look like to plug into the formula. R squared. if I multiply, 2 times 4 is 8, that's 8rp, and then my last term would be 16p squared. So once again, FOIL if you prefer, or here's the formula as well. Okay, that's number 2. Number 3, 4, so just some more squaring a binomial problems. Here's one with a decimal, that's okay. Use your calculator, it's fine. Now here is the first one using that a plus b, a plus b, a minus b pattern, and that's a squared minus b squared. Or you can FOIL. How many times have I said that today? So I could just FOIL, right? T squared minus 7t plus 7t minus 49 would be my 4 terms. But then the 7t's cancel. Or I could just do this, t squared minus 7 squared, t squared minus 49. So I think the formula is shorter in a problem like this, but that's the way you're meant to get to the answer for this. But again, FOIL is fine. All right. So this next chunk of problems deals with that pattern, the a plus b, a minus b. Here's one where you have to rearrange. Okay, so we saw one like that in the notes, or just FOIL. Is anybody keeping track of how many times I'm saying that? Just FOIL. Another rearranging one. Okay, so if I rearrange that first parentheses, I could write it as 3b to the third minus 5ab, and then the pattern fits, and then I can use the formula. Okay, let's do this one. Here's a fraction problem. So it does look like it follows that a plus b, a minus b pattern. It's just that the minus is first, which is okay. So a squared minus b squared. So I would square the first term, 1/2 b squared minus, and then square that second term, 2/3 t squared. That would be 1/4 b squared minus 4/9 t squared. So when you're squaring a fraction, you can write it twice and just multiply across, or really you can just square the numerator and square the denominator. That's how I do it. Okay, good. I think that does look familiar. I think it was similar to a problem in our notes as well. Okay, oh, and that's, look at that. That is literally from the notes. That's one of those longer problems. So these last few are longer, multi-step problems. So see the notes for number 14. Maybe your numbers will change, but it looks like maybe they won't. So enjoy if that's the case. All right. 15 and 16 are similar to each other. Yes, so 16 is kind of like our last notes example. I'll just show you 15. They're kind of similar. So the idea is, let's see, b plus g is the same in both of those parentheses, and then the 8 is the same. So that's sort of like b. So you have this plus 8 and then this minus 8. So a plus b, a minus b. That's a squared minus b squared. So if I plug in, I could do b plus g squared minus 8 squared. Using another formula for the square of a binomial, that would be b squared plus 2bg plus g squared for that parentheses, and then minus 64. So that's, I know I just did that really fast. I know you can pause and rewind. That's why I'm going kind of fast. That's one way to do it. Or I'm not going to say FOIL, but you can distribute. Okay, so let the formulas go if you prefer. If you prefer to just distribute, that is fine. So that would be b squared plus bg minus 8b. And then here's another plus bg, my second row, plus g squared. I don't have anywhere to line that up. I'll make a new column, g squared. And then minus 8g. And then my third row here, distributing the 8, plus 8b, plus 8g, and then minus 64. So it's kind of a weird lining up situation, but I hope you can see that you can combine like terms. Here's b squared. Here's our 2bg, right? 1 plus 1 is 2. There's 2bg. Minus 8b and plus 8b cancel. There's plus g squared. So that's what you would have gotten by squaring those first parts, the b plus g squared that I showed you. That's that formula right there. The ag's cancel, and then here's the 8 squared. So anyway, many ways to get to the answer. If the formulas are clicking for you, that's great. If they're overwhelming you, please know that you pretty much can just distribute for all of these problems. You might have a slightly longer problem, but if it's easier for you, that is just fine. Okay, good. So this is the end of lesson 23. There's only one more in our unit, which is lesson 24, and it is shorter and easier than what we just did. Multiplying is the big topic, I think, in this unit. So look forward to a slightly shorter and hopefully easier lesson for the last part of our unit. So lesson 24 on division, last part of unit 1 before our test. Okay, as always, let me know if you have any questions, and I will see you soon. Thank you.